Hello guys, a quick DIY video for showing you how to modify your Christmas light sets in order to operate them from AC instead of the batteries. We all have laying around some old small transformers like this. This one is coming from a wireless phone. It's in Uniden and it's a 9 volt DC, 200 milliamps. Any of these small transformers will work as long as they're like 4.5 or higher till 9 or 12 volts. They will work, and they need to be 150 milliamps and up, but no need for the big ones. The small ones work. The idea is that these little LED circuits, like this one has 60 LEDs on it. It drains quite a lot of current, and when you have 3 alkaline batteries brand new, this won't last more than 20 to 24 hours, and I like to turn them on, so the batteries get quite expensive. I found available on the web, actually from Amazon, these small DC to DC converters, these small modules. It's a LM2596, and you can buy them in a pack of 5 units for $10. So a board like this is less expensive than buying 3 alkaline batteries for your Christmas light sets. So I'm going to show you what to do, how to do it. Very easy, simple. You will need a small soldering iron and of course a small multimeter to adjust the power module. So the first thing to do is to of course remove the batteries. I also remove the set of springs and metal clips here at the back, and I make a small hole for the transformer cable. So I'll do this, do a little bit of work on this, and I'll get back to you. Okay, first modification is to remove the metal clips that won't be used. You don't need them anymore, and to cut off one of the plastic separators inside the box, because this module is nice. It just have the proper thickness. Once it goes in there, you can close the lid and the module will stay in, but in order to achieve that, you just need to remove one of the plastic piece here. Make a hole, run your AC adapter cable, and when you're going to look at your module, you're going to find that either printed on the top or on the bottom, there are 2 lugs for input and 2 for output, and one is out minus, out positive, because this is DC, and same thing on the input, in minus and input positive. So you have to identify from your DC power supply which of the cable is the positive and which one is the negative. Just plug it to the AC outlet, use your voltmeter and identify which one is which. So I can see a reading here, a positive reading of 10 volts, so it means this cable here is the positive. If I had my connectors on reverse, I would see a negative reading on the meter, indicating me that I'm on a reverse polarity. So I know now this one is positive, this one is negative, so I'm going to use my soldering iron and I'm going to solder this cable to the N plus and the other one to the N negative. We can now see that the DC current input is connected to the board. The red LED is indicating that. If you feel this annoying because this is not switched, you can just use your soldering iron and remove the LED from the board. I think it should work. I didn't try it, but it should not be part of the circuit. It should be only an indicator lamp, so it should work. Now the second thing to do to this board is to set up the proper voltage of the output to match your box. If you have a 2 battery box like this, you need to set up the voltage for this board to be 3 volts. If it's a 3 battery like this, you need to set it up to 4.5 volts. So the way to do this is to use a small screwdriver, use your meter, touch the positive rail and the negative rail. And now we can see my meter is at 4.404 volts, which is not enough. So I'm going to screw this little adjustment screw until I read 4.5 volts, because I'm replacing 3 batteries with 3 times 1.5 is 4.5, and I've got now 4.5 volts reading. So the next step to complete this project is to hook up the negative wire here to the negative terminal of the battery post, and the positive wire here to the positive post on this terminal right here, and this cable right here, and the circuit is going to be complete, and our lamps are going to work from the AC outlet instead of the batteries. So I'll do this and get back to you. Okay, my circuit is now completed. The AC adapter is plugged into the outlet. There's no more red light. There's a small LED on the board. I just took it off, and my positive connector here is hooked up to my positive through this wire here, and the negative cable that was connected to that battery terminal is now connected to the board. So when I turn it on, I got 4.5 volts going into the LEDs. Circuit is on. Turn it off. One thing that could be done, like if you don't want the board to keep the power on the board, you could use the switch on the input side. It means have the switch on this side on this cable instead of on the output, but it requires a little bit more modification, because there is a resistor on this side feeding the LEDs, and some of the boards, some of these Christmas light sets, they have a board like this inside with a small built-in timer, which is nice, is that you can either turn them on and they will be constantly on, or you can push it to the far end side of the switch on the third position, and it's going to kick in the timer, and this will turn on the light for about 6 hours, and it's going to turn off the lights, and the next day it's going to turn on the lights again. So that's pretty cool, that little timer. On this circuit, it's simply a switch with a resistor. So if you want to put the switch on the input side, you have to make sure you keep the resistor on the output side to make sure it's in the circuit with the LEDs. But like it is now, it works. It's perfect. I just put the cover back in place like this, and my box is ready to be used with the AC adapter. No more batteries, and I did this for only $2 Canadian, probably cheaper than that if you're a US citizen, but it's definitely cheaper to do this than to buy 3 alkaline batteries and keep throwing them to the garbage. Thanks for watching.